Let's talk about VTP next. This is enough to understand. This is a proprietary protocol of Cisco. We don't use it very much in the enterprise network now. Except for exams. When you are preparing for the exam in the future, we'll send you the document. Just enter 3 commands when you face. This thing is not very important. VTP is called Virtual LAN Trunk Protocol. It is used to create VLANs in batches. You can see. There is a server here. There is a client. Indicates that this is a CS architecture. If there are many switches in the enterprise. Assuming 100 switches. But what if you have 1000 VLANs? Too much work. You have to manually create 1000 VLANs on these 100 devices. Then we can now choose a switch as server. Others are treated as client. I configure VLAN on this server. Then sync to other devices. Reduce workload. We'll get to that later. Cross-VLAN intercommunication between Layer 3 VLANs. Let me briefly talk about how to configure it. It's enough for everyone to understand. First we enable VTP. I change a VTP mode. It changed to server. It changed to client. They assign a password to each other. Name each other. It creates VLAN here. It can be seen here. This thing is not needed now. For the client. It cannot create VLANs by itself. Only it can create. Okay. We're done talking about VLANs. Then we look at the next requirements. Actually, VLAN can divide the broadcast domain. That is, there is no communication between different VLANs. Neither unicast nor broadcast. But it also limits the ability of the host to communicate at layer 2. After we divide the VLAN hosts between different VLANs, there is no way to communicate with each other on the second floor. They are not mutually imitable. So I just told you. For the entire VLAN. It's more about wanting to isolate broadcast traffic. And to differentiate and isolate overall data. For example, for different departments, I can rely on VLANs to differentiate different traffic. Make it impossible for them to complete mutual visits. But in fact, in our daily practical application, there will also be a need for mutual visits between hosts. We tend to be more. Treat VLAN as a means of security isolation. But usually, sometimes we also want to exchange visits between hosts. That is, I hope the host unicast can still communicate. We want more to suppress its ability to broadcast. Therefore, the VLAN we refer to hopes to make it unreachable between the 2 layers. But we hope that there is still communication between the 3 layers. That is, we want the 2 hosts to be in different VLANs. However, it is still possible to communicate data. Switch-based networking. Isolation of broadcast traffic through VLAN. Then by itself it can narrow down the scope of the broadcast domain. What if unicast communication is desired between devices across VLANs? Can't it work? That is to say, we hope to realize layer 2 broadcast failure. But it is hoped that unicast between different VLANs can be communicated at other levels. If we want to discuss the issue of unicast, we also discuss on the second floor. Neither unicast nor broadcast. If I want the host to communicate now, it can only communicate across network segments. That is to say, only rely on the switch to query the MAC address table. Corresponding VLAN. Corresponding interface. Forward accordingly. This is not working anymore. You can't complete the communication. So now we can only communicate across network segments. If communicating across network segments, it is known. Access as a host across network segments. is looking for a gateway. The gateway helps it communicate across network segments. Then we have to mention devices such as routers. Wait a minute, I will introduce a router. We will use a representation of a router across network segments. Routing table. Everyone should be familiar with this. But we all know. Now this is the basic forwarding of some addresses. We can find gateways across network segments. Then the router directly looks up the table and forwards. But now there are more VLANs. How can we communicate with each other on top of VLAN? This is called mutual access between VLANs. Inter-VLAN access needs to use the routing function. Between different VLANs. There is no way to communicate on the second floor. If you want to communicate, it can only be forwarded with the help of three-layer query routing table. So, we can achieve, even after deploying VLAN, we can still communicate across network segments. This is an effect we want to achieve. It has several ways to implement. One of the easiest ways. This thing is not commonly used. Called one physical connection per VLAN. Let's see how it goes. The PC on the left is assigned to VLAN 2. This is an access interface. Belongs to VLAN 2. The right side is divided into VLAN 3. This is an access interface. Belongs to VLAN 3. Router as a layer 3 device. Its interface is a layer 3 interface by default. It has no way to process data carrying VLAN tag. So the switch is connected to this interface of the router. It must also be an access interface. These two must also be access interfaces. So how do host A communicate with host B? They cross VLAN. I can choose a method. Is to configure the access interface on both ends of the switch. And both of them are VLAN 2. Both of them are VLAN 3. As a different VLAN. Under normal circumstances. I now send a broadcast data. So broadcast data comes in here first. Can go out here. Get to the router interface here. Router interface does not forward broadcast traffic. So the broadcast data will be isolated here. So this data can't reach here. Secondly, if I send a broadcast data. So here you go. Mark VLAN tag 2. Then it has no way to send out from VLAN tag 3. So this data cannot reach host B. I want to send a data in the future. If it is a broadcast data then. In fact, it can only be circulated in the entire VLAN. I can't send it to host B. Because it is isolated by VLAN. These two interfaces are on different network segments. You have to distinguish this. If we want to communicate at layer 3. To use routing. A router is two interfaces and two network segments. So the two of them are not on the same network segment. Assume that host B is in the 1.0 network segment. Host A is the 2.0 network segment. Host B wants to access host A. Layer 2 communication between different VLANs is definitely not possible. So it has to go 3 floors. Layer 3 traffic must reach the router. Let's talk about the process. Traffic sent here. The interface of access is marked with tag 3. And go from here with 3. This is an access interface. Come out, strip off 3. Then go into the router here. So what the router receives is a complete data. Go to the 2.0 network segment in the future. RA queries the local routing table. It is found that the 2.0 network segment is sent from the local interface. The next hop is this interface of host A. It comes out. It also sends out a blank data frame. Go here and put VLAN tag 2. Come out from here and remove VLAN tag 2. Then send to host A here. That is, all interfaces are access interfaces. Only the switch is configured here. Both of these are tag 3. Both of these are tag 2. Tag 3 and remove tag 3 here. Tag 2 and remove tag 2 here. When the final data passes through these devices are blank, it can isolate the communication between the hosts at the second layer and help them communicate at layer 3. But you will find a problem. When we are communicating at layer 3, these two hosts actually cross the network segment. I will explain to you. You will find, when we were doing the experiment just now, usually when we are doing layer 2 VLAN experiments, we all prefer to put it on the same network segment, because it's easier to say. Let everyone intuitively see some of its corresponding problems. But in fact we are working in real. Different VLANs will be divided into different network segments. I give a simple example. If you want to exchange visits between different VLANs, we first need to use the 3-tier function. That is routing. Because on the second floor we only check the MAC address table. We just looked at the MAC address table, VLAN ID, interface, and MAC address. They are indispensable. As long as the VLAN is unreachable, absolutely no access to the second floor. So the second floor can't move. Only 3 floors. If it is a 3-tier routing, then everyone should know. For example, I divide host A into VLAN 10. Assign host B to VLAN 20. And they are both on the same network segment. You have to think about a question. If the same network segment, it wants to access a device like this, it sends an ARP broadcast request. Directly request the other party's MAC. Then it is impossible to communicate directly. Because it now sends the broadcast. Will not reach this device. That is to say, is unable to communicate. I can't get through the second floor. When you are encapsulating data, you will let this PC directly access. Request its MAC. Then you can't go. Because the data cannot come through. Request if the data is not available. Unable to encapsulate MAC. So if it is across VLAN, you are also configured to the same network segment. It can't communicate. We only have one way now. We go 3 floors. Access between 2 PCs across network segments. You have to configure the gateway for them. Often routers forward across network segments. It is impossible for you to configure the same gateway address for 2 devices. That is, if 2 devices are in the same network segment, gateway cannot be configured. So, we forward data across network segments. It is often configured as different network segments. For different VLANs, you have to walk 3 floors. You let this data request the gateway's MAC. Data must first reach the gateway to check the routing table. So we are on the project. Usually it will be divided into different VLANs and divide into different network segments. This is the gap between our experiments and real applications. The above mentioned is a physical connection per VLAN. When you learn NP in the future, you will talk about ARP proxy. In the future, there will be an ARP proxy in the VLAN. We only learned one ARP proxy in the NA phase. Is the easiest one. Then you will know that there are other ways to achieve. Let's look down. Let's go on to talk about a slightly more complicated knowledge point. One-arm routing. The difference between the single arm and the picture just now is that there are 2 lines in this graph. This picture has only 1 line. 1 physical connection per VLAN. It is called a line for each VLAN connected to the router. This has a router interface. One-arm routing refers to the. This is only one to undertake the traffic of multiple VLANs. In the future, there will be more than just these 2 flows. Can be VLAN 4 or VLAN 5. Can connect. Then all go this line. Single arm with only one line. Let's talk about how it's done. There is a trunk written here in the middle of it. Different from before. Just here is access. Now is the trunk. So the configuration of the trunk is demonstrated here. I just told you. The interface of the router is a layer 3 interface. It doesn't recognize anything about the tag. If configured as trunk here. Trunk is released for data. Then when the data is sent. If their current native VLANs are different. It may be posted with a tag. Now this interface is not recognized. So it creates some problems. Everyone should know. The interface of the router is a layer 3 interface. It cannot configure layer 2 VLAN. Therefore, the layer 3 interface does not recognize the tag by default. It has no way to receive and forward data. But one such implementation is shown in the figure. That means it will definitely come true. The interface of the router does not recognize the tag. I want it to recognize. At this time, the physical interface of the router is not working. We can make a logical interface for it. Then I can, based on a physical interface, give it a few logical subinterfaces. For subinterfaces, I can under a physical interface. Based on it has many subinterfaces. Let these subinterfaces serve different VLANs. Like this picture. 2 interfaces on 2 routers. We now let an interface of a router use as 2 subinterfaces. What are the characteristics of this subinterface? First, it can configure the IP address normally. To us. The host has to configure the gateway. Configured on subinterfaces. It can be configured with IP normally. Secondly, this subinterface can also have layer 2 functions. That is, it can handle tags. Now means that only one line in the middle will be able to complete. Trunk can be done between them. Let me briefly talk about the function of the subinterface. It now receives a data. This is the access interface. Tag 2 here. Through this router. We then proceed to the trunk interface. Suppose its native VLAN is 1. Came out 2. Then when carrying such data with tag 2. When entering this subinterface. The subinterface can receive tagged data. And strip the tag. It has the ability. Simultaneously. Another subinterface can process the data of VLAN 3. That is. It now looks up the table. It now goes from segment 2.0 to segment 3.0. After checking the local is a direct route. To come out from another subinterface. When it comes out. Add another subinterface VLAN. Is tag 3. Then send. Pass through the trunk interface of the switch. Then when passing through this access interface. Strip off the tag. Then forward to host B. Complete the communication between the two of them. Is equivalent to. We extended this interface to it. In this way, the problem of insufficient router interfaces can be alleviated. But in this case, it will have some other problems. We have another way. Layer 3 switching. Well, first you need to know. There are actually a lot of problems with one-arm routing. So it's not very common in corporate networks. May be seen in small businesses. Medium and large enterprises do not use it for a long time. Because it's very unoptimized. Including many switches now. In fact, it's all 3 layers of switching. So now one-arm routing is rarely practical. But we have to learn it. This knowledge is very important. First, its first question. Single point of failure. That is to say, once this thread is broken, you will find all business is now closed. This is still 2 VLANs. Both VLAN 4 and VLAN 5 can be connected to the switch. Then between all these VLANs, all visits to be made follow this line. If this thread is broken, it will not leave. This is the most important question. Single point of failure. Second, for the router, it will have additional performance loss. The main function of a router is to responsible for IP addressing and forwarding. This is in terms of 3 layers. Address forwarding is a router in itself. This processing tag. This is not someone's job. So where are you now? For our router, configure the function of the second layer on it. Then there will be some additional loss on it. This is the second point. And a third point. This link will have certain congestion problems. That is, the current communication traffic between VLAN 2 and VLAN 3 go this way. In the future, if you access other VLANs, you will not take this route. There will be a lot of traffic on this road, been piled on this one line. This is pretty much the same as the single point of failure problem. Interaction between all traffic. All follow this line. It is not optimized. So one-arm routing will have such a problem. So how to solve it? One of the most common ways we use now. Layer 3 switching. That is, stop letting the router do the job. Why add a router here? Just want to have its routing function. I want to configure an address for it. I want to configure a gateway for the PC below. Configured on this router. Then just get a switch now. Let the switch function as a router. That is, this switch can be used as a layer 2 switch. Layer 3 routing function can also be added. The routing function is to give the interface PIP. And as the gateway below, it has a routing table. Just complete the lookup table forwarding. It just wants to configure an IP to check a routing table. So it doesn't need a dedicated router. As long as the switch can do the job. So now there are new devices. Layer 3 switching. For switches, it is now a layer 3 switch itself. It has certain 3-layer functions. It has its own routing table locally. And we can configure IP under the VLAN interface of the layer 3 switch. We can enter the VLAN 2 interface of the switch. Give it an IP address. As the gateway of this 2.0 network segment, I can enter the VLAN 3 interface of this switch. Give it an IP address. As the gateway of this 3.0 network segment. Then when we go to data forwarding, PC directly accesses across network segments to find the gateway. You can understand it as this switch. It has a fake router inside its body. This router also has its own interface. This interface is called SVI. This is the virtual interface of the switch. There is a routing table in the router. The router has its own interface. This interface is a VLAN interface. Let's look directly at the configuration. Let's first configure this one-armed route. I deleted this device. Turn it off too. Wait a minute, I reconfigure. Then I add a router in. The router needs to be connected to this device. If you want to add wires to the equipment, you have to turn off this device first. Otherwise, the device cannot be connected. And I tell you, after you have created on the switch, even without saving the configuration, this VLAN is still there. I open it. After opening, we are going to configure an IP address for this device. 192.168.10.1. Both of them have to cross network segments. Otherwise, there is no way to configure a gateway for it. It belongs to VLAN 10. Then it will have a gateway. 192.168.10.254. Configure PC22. 192.168.20.1. 24-bit mask. Next configure the gateway. 192.168.20.254. OK. This is their address plan. Then I'll reconfigure them. One arm is. Now when the router is connected to the switch, use only one interface. This arm carries the traffic of multiple VLANs. So let's revisit. For routers, one of its interfaces must be able to handle VLAN 10 and VLAN 20 data. The data of VLAN 10 is handed over to one of its subinterfaces for processing. The data of VLAN 20 is handed over to one of its subinterfaces for processing. We can configure them differently. We need to change the PC address. This is PC1. This is PC2. This is the switch. Slightly slower. This is the homework I left for you today. So when I configure, everyone should look carefully. The IP address is 192.168.10.1. 24-bit mask. Then we need to configure a gateway for it. 192.168.10.254. This is PC1. Next look at PC2. IP 192.168.20.1. Mask is 24. Gateway is 192.168.20.254. Two PCs are configured. Then we come to the switch here. Show VLAN brief. Let's check if there are these two VLANs. Have VLAN 10 and VLAN 20. But you will find the interface we divided just now is gone, because it restarted. But how does it save the command on the switch now? Then let me tell you. Type right here. Then press enter and it's OK. We go to the switch. A VLAN has been created on the switch. We can directly divide the interface. E00 interface. This is the interface connected to PC1. Divide into VLAN 10. Switch port mode access. Then, switch port access VLAN 10. Then we enter the E01 interface. It is connected to PC2. We should change the mode to it first. Switch port mode access. After that the difference is. This time the VLAN should be written as 20. After that, we have to go to the 02 interface again. This is the interface connected to the router. Before we change its mode to trunk, we are going to enter a command. Switch port trunk encapsulation. This is an encapsulation mode we have carried out. Then enter a question mark. We have two common. One is called .1Q. One is called ISL. .1Q is the public mode I just told you, called 802.1Q. ISL is proprietary in Cisco. We use ISL by default. So we manually change it to .1Q here. Now we are going to use .1Q. For example, many real machines with newer mirror images. You don't need to enter this command. But there are some old equipment. Still have to enter this command. In the emulator if you don't type. Instead, go directly to modify the schema. It will report an error. Before you enter mode trunk. To enter this command first, change its mode to .1Q. Because the image of many new Cisco devices is directly .1Q. No more ISLs. Then under the interface, We can give it a pass on 10 and 20. In fact, it is allowed by default. Let's take a look. Switch port trunk allowed VLAN. I put a question mark here. For example, I want to add a certain VLAN now. To allow it to pass, just write add. More commonly used is all. Is to let all. Word means that you can write which one you want to release. This except is. For example, if you want to deny a certain VLAN to it, just don't let it go. Then just add what you don't want it to pass. I pass 10 and 20. Separated by commas. Do show run interface E02. Let's check. We can see now. We modified the overall model to .1Q. Changed to trunk. Then released 10 and 20. Here is some simple configuration we did. This does not mean that you have to type. I'm just showing you. Only the two commands to change the mode must be entered. Our switch is actually done. We just need to change it to trunk. Then release 10 and 20. In fact, it will be released by default. Then we're coming to the router. The router will do more operations here. When we are doing one-arm routing, subinterfaces of the router will be used. So before you use the subinterface, first thing you have to do is to enter its physical interface. Interface E00. After entering the physical interface, just open it. No shutdown. After opening, show IP interface brief. We did not configure IP for this interface, but I can also open. Here we have to configure the gateway for the PC below. On the subinterface. Subinterfaces serve different VLANs. How to distinguish which VLAN it serves. Then we have to create subinterfaces and specify which VLAN it belongs to. The router cannot receive tagged data. So actually, there are subinterfaces before the router enters the inside of the frame. In fact, just remove the VLAN tag for it. Subinterfaces can handle VLAN tags. Accessing the subinterface is also simple. Interface Ethernet 0.1. Enter a question mark. This point is usually consistent with the VLAN below. So many subinterfaces. It's all a range you can define. So this has nothing to do with the VLAN below. But usually, we will write a few subinterfaces for the VLAN. It is VLAN 10. Write 10 later. Press enter. You can see. I'm in the subif now. Let's check. Do show IP interface brief. We'll find out. There is a 00.10 in this list. It is also in the upstate. So this is what we call a subinterface. The subinterface has been created. After creating, we are going to configure the address for it. Before configuring the address, we first have to enter a command. We're going to assign .1Q to it too. Then we write a 10 in the back. The meaning of this 10 is different from the 10 above. Here's this 10. It refers to. Now this subinterface has the processing capability for VLAN 10. Tag VLAN 10 here in the future. When passing here, I am here if I write this command. Then it can strip the VLAN 10 tag. So this VLAN 10 actually operates on the tag. So the 00.10 we just wrote. It's actually nothing. It is just to identify that the bottom is now VLAN 10. No matter what to write. will not affect the results of today's experiment. It's just that it's easier to remember when we write like this. OK. We press enter. The subinterface can process the data carrying the tag. Anyone who comes in will strip the tag. Anyone sent from here will be tagged. This is our stripping of the tag. If we want to achieve PC cross-network segment mutual access, it must be configured with a gateway. The gateway address is configured on the subinterface. 192.168.10.254. Open it. Opening is a habit. In fact, it is enabled by default. Because you opened the physical interface. It opened. But I hope you will develop a good habit. Make sure this interface is open. Afterwards, we also configure the 20 interface in the same way. E00.20. This is the second subinterface. After coming in, we still assign .1 queue to it first. It is processed for VLAN 20. Then configure the IP address for it. 192.168.20.254. 255.255.255.0. We now have the interface configured. Let's check. Show IP interface brief. We can see now. We do not configure an address under the 00 interface. Then under the two subinterfaces, we configured 10 network segment and 20 network segment. Act as a gateway for two PCs respectively. So let's talk about how they work together. Before we say, just look at the experimental phenomenon. I am now accessing 20.1 from 10.1 here on PC 1. So now can I communicate? Let's take a look. Ping 192.168.20.1. It works now. Cross-network segment. Walked 3 floors. And we also divide the VLAN. We are taking the one-armed route. Let's make a summary. We first send out a data here. Here. Belong to VLAN 10 and tag 10. Released 10 and 20 here. And the default native VLAN of the interface is 1. So I keep this 10 and send it over. Send here. Hand it over to the current subinterface 00.10. It is located exclusively at .1Q10. It is designed to handle 10 tags. Then a subinterface like this. When receiving data, this 10 will be stripped off. So in this 10 it is stripped off. Then the router officially starts processing. After the router is processed, query the local routing table for forwarding. In the routing table you will find the next hop will be VLAN 20. You may not understand this. We'll talk about that later. We know it's coming here later. Before sending down. When sending, it needs to go through the local .20 subinterface. Then put VLAN tag 20 in it. Then send out. Our trunk needs to be released. After release, it came to the access interface with 20. After stripping off the 20, pass to PC2. So let's now look at the routing table. Show IP route. Now we will find out. Now we actually have to go from the subinterface. Because what we are configuring now is the subinterface. Because we are configuring the address for the subinterface. And we are now using the normal subinterface. So it goes through the subinterface. When its next hop matches the upper subinterface, then it will mark the corresponding tag on the subinterface. For example, I query to go to network segment 20. My outgoing interface is now .20. Then I'll tag 20. A data comes in. If the data is processed by the subinterface .10, I'll take this 10 off. So for subinterfaces, an interface to receive data. Strip off the tag. Send data. Tag. Who does this subinterface belong to? We'll strip whoever and beat whoever. And to make an emphasis to everyone. Inside Cisco, there is a capability called ARP broadcast in the subinterface. We just missed a link. PC this sends a data. Here. It requests the MAC of the gateway. Subinterface. The subinterface wants to send an ARP request to the 20.0 network segment. PC1 come here now. Request gateway MAC. The gateway is going to request the MAC of PC2. The gateway is now going to forward data. But for subinterfaces, Cisco subinterfaces can send out ARP broadcasts. Okay. This is also an experiment that I will leave you with today.